Hi, welcome to the second in a series of familiarization presentations about the new Citation 10. I'm Jeff Johannsmeyer, the Citation 10's project engineer. Each of these sessions will cover a different portion of the changes made during the design and development of the new airplane. Today I'll be talking about changes made to systems and avionics. Let's start with a quick refresher on the overall program scope for the new 10. We have new, more powerful engines, a longer, more spacious cabin, completely new interior fittings and styling, all of which we talked about in the last session. Other changes include the Garmin G5000 avionics system, AutoThrottles, and a host of maintainability and reliability improvements. Starting with the environmental and anti-ice systems, you'll find a host of minor improvements that add up to big gains in reliability and performance. One of our most anticipated upgrades in the new 10 is the air-bearing air cycle machine. This new machine eliminates the oil bearings and promises greatly improved reliability with less maintenance. No oil bearings means no oil to monitor and change. So to control this new ACM, we've designed a temperature controller here at Cessna that has a touchscreen interface through the Garmin system. Pressurization controls are also handled through Garmin touchscreens, which eliminates the old dial gauges on the co-pilot side of the panel. The 100-hour recurring inspection for the baggage aneroid and isolation valve is being increased and aligned with standard MSG3 intervals. Also, the difficult-to-access inboard wing anti-ice RTD has been relocated a little bit farther inboard and given a dedicated access panel. The service air system has been completely redesigned for the new 10. The goal was to eliminate cases of moisture getting into the baggage and cabin door seals. To do this, we've relocated the rat probes to dedicated branches, which separates the constant moist flow through those probes from the static flow in the door seals. One of the 3 regulators and one of the 5 check valves have also been eliminated. We've tapped service air downstream of the pylon pre-coolers now, which has allowed us to eliminate some redundant plumbing. And the vacuum ejector has been moved into the warmer tail cone from its old location in the belly fairing, which prevents freezing on colder days. The updated Pitotstatic system represents another maintainability improvement in the new 10. The Pitotstatic system has been completely redesigned to be self-draining. Much like the system on the Sovereign, the static ports are now the low point in the system, which means that any moisture in that system self-drains through the static ports. This has allowed us to eliminate the 4 difficult-to-access manual drain valves located up under the instrument panel, but the 2 easier-to-access drains in the nose avionics bay are still there. We've also picked up the Sovereign's pitot probes and flush mount static ports, but due to the fuselage stretch and the redesigned fairing, those static ports were relocated just a little bit to match the new fairing contour. And lastly, we have new Garmin air data computers which contain dual static source error correction curves, which optimizes data correction for gear up and gear down configurations. The flight control system is largely unchanged, but we've still made a few strategic improvements. To interface better with the Garmin avionics, we now have Garmin autopilot servos for the roll and pitch axes. The lower rudder yaw damp actuators are brand new, and the YSAC computers that control the upper rudder are a brand new Cessna design. Those YSACs have been relocated from up in the vertical tail to the avionics rack above the baggage compartment, which makes them a lot easier to access. A new speed brake handle, which you can see here in the picture, was designed to match the new AutoThrottle from a styling and functionality standpoint. The control wheels and columns have also been updated to match the new cockpit styling. Control cable routings are largely unchanged, but since the cabin stretch required new cables, we took the opportunity to clean up the brackets, reduce cable chafing, and make things easier to rig. The flap system has been given a thorough overhaul. New mechanical actuators include visual trip indicators to help diagnose faults in the flap system. You can see this feature in the 2 center images. The lower one shows the spring lever in the normal position, and the upper one shows the tripped position, which allows you to quickly identify which actuator might have contributed to a jam without having to go in and test each individual actuator. The mechanical actuators interface with a new central PDU motor, an updated electronic controller with enhanced onboard diagnostics, and a compact solid-state power relay box. The resolver converters have been eliminated entirely. Up in the cockpit, the flap handle, seen on the right, has been redesigned for greatly improved resistance to FOD, which will help keep carpet lint out of those optical sensors. It also has improved detent feel, which will prevent the handle from getting inadvertently stuck between positions, causing a failure message. Also, we've eliminated the slats detent entirely. In the new design, the slats automatically deploy when you extend the flaps. Landing gear. This is another area with a host of minor but significant improvements. Due to our gross weight increase, we've introduced a new main landing gear tire. It's the same size as before, but it cannot be used as a retrofit on the legacy airplane for various reasons. We've designed a new brake metering valve, which greatly improves brake feel for the pilots and reduces the grabbiness and judder that can be felt in the cabin with the old design. The oleos have been upgraded with a number of improvements for better corrosion resistance and maintainability, which includes better plating and an improved design for the fill ports. The new Garmin G5000 avionics suite is the centerpiece of the new Citation X's cockpit. The three 14-inch displays immediately grab your attention, and there's also 4 touchscreen controllers, 2 in the center and 1 on each side console. The touchscreens are the primary means of input for the avionics system, but they also contain interfaces for many other aircraft systems like climate control and pressurization. This has allowed the design team to simplify and declutter the instrument panels and the center pedestal. Many of the old switches and gauges are gone entirely, as they're either automated or part of the touchscreens. Many of the switches that remain have been relocated onto the pedestal, logically arranged by system type, which allows both pilots to easily reach them. The new digital standby instrument seen in the center of the instrument panel combines into one display the functions of 4 backup gauges in the old airplane. The G5000 system has a vast range of capabilities. I'm only going to touch on a few of the more interesting ones here. Positional information comes from either dual GPS receivers or from the new LightF hybrid navigator. This hybrid navigator combines GPS data with a precision gyrocompass, which provides really accurate IRS-like performance at a fraction of the cost of the old IRSs. The onboard solid-state Garmin weather radar is standard and can be supplemented with a subscription-based satellite weather radar package if the customer wants. The G5000 system supports all of the latest navigation and communication techniques, which includes RNP less than 0.3. We have ADS-B in and out capability, and we also have growth capability to accommodate pretty much all the future technologies that are on the drawing boards. The AutoThrottle is an exciting new feature for Cessna. This function allows the crew to fly hands-off from the throttle from takeoff until touchdown. All you have to do is advance the throttle for takeoff, engage the system, and the AutoThrottle and autopilot can fly the airplane along its flight path all the way down to landing, including touchdown. The speed protection function is particularly interesting. If the airplane slows down enough to approach a stall, the AutoThrottle can turn itself on and automatically increase thrust to prevent a stall. A similar function works to reduce power if the AutoThrottle system senses an overspeed. The new AutoThrottle quadrant, seen here in the pictures, features new styling and a new way for engaging reverse thrust. From the idle detent, you now lift the lockout triggers on the throttle levers and continue to pull aft to deploy the thrust reverser buckets to increase power. The electrical systems on the new 10 have been comprehensively updated. The new airplane features a true split-bus electrical system that's based heavily on the successful Sovereign architecture. We've also added 2 transformer rectifier units, or TRUs, for backup power. These devices can generate DC power from the engine alternators, meaning there's now 4 sources of generated DC power. So even if both DC generators fail, as long as you have one alternator still turning, you've got ample DC power available. This allows us to keep the MFD and PFD, the main 14-inch displays, powered in EMER mode, which makes the airplane a lot easier to fly in the event of a power loss. We've also made a real improvement in maintainability with the diagnostic features on the new airplane. We have extensive diagnostics and data collection ability through the Ares 2 system, which will greatly enhance troubleshooting. Also, nearly all of the PCBs on the airplane now have built-in diagnostic features, which will aid troubleshooting at the board level. Another maintainability improvement, the exterior antennas have largely been upgraded with a quick disconnect design seen in the center picture, which will greatly reduce replacement time. And most of our exterior lighting has been changed over to LED bulbs for longer life. That brings us to the end of this update on the new Citation 10. Once again, thanks for your time and attention, and be sure to check back soon for the next installment in the series.